Thank you very much, Vincent and Grégoire, for this amazing presentation, and welcome everybody to this very first API Platform Conference. So, in 2015, I started to work on a side project. Basically, I was already working at Letl.coop, our company, and I was tired to have to write the same features, to fix the same bugs, to rewrite almost the same bad code at every project. It was the beginning of the single-page applications, the rise of JavaScript client-side, and we were embracing that, and we were creating new APIs almost every month. So I started to work on a tiny project, an internal project at the beginning, and it was the beginning of what will become the API platform framework. So as you can see, the first version was about only 2,000 lines of code. As of today, the project contains more than 8,000 commits, pushed in 17 Git repositories, written in PHP, in TypeScript, with Docker configurations, and many things, many features. The main repository called Core, the Core API Platform Library, has been downloaded almost 9 million of time. The project has a lot of stars on GitHub, and as you may know, API Platform the server-side components of API Platform are a standalone PHP library, but when you install the project, it comes with the Symfony framework and this library, and the integration between Symfony and API Platform called the API Platform Bundle. And this bundle has been awarded Best Symfony Bundle by the Symfony community. So it has been a long way, and I'm very proud to be here today with you, physically, to speak about this small piece of code that has become the API Platform framework. Of course, even if I wrote the first commit, most of the work has been done by a lot of other people that I want to thank today. So as of today, there is more than 600 contributors. And when I mean contributors, I don't speak only about developers, because a lot of people have done other things. For instance, Laurie Sorio, that I want to thank, created the logo, the website, and most of the artwork of the project. Many people contributed to the documentation, so there are a lot of other tasks than code that has been done. But also, of course, thank you to all the developers writing new features and fixing bugs in the project. Also, there are 15 members of the API Platform core teams, maintaining the PHP code, the JavaScript projects, the Docker setups, and things like that, that are doing hard work almost every day of the year to make the project active. So thank you to all of them. There are a big community online, helping other people to use the framework, especially on the Slack channel. There are thousands of users around the world. There are talks done in many countries every month, or almost every month. And today, we are 500 people in Lille and online to assist to this very first API Platform conference. So thank you, everybody. We will have 15 amazing speakers. Some will speak in French, so don't hesitate to go to the French stage if you are speaking French, because you will be able to see all other talks online after the conference, and some will speak in English. This community is that big because it is welcoming. And you have to know that you don't have to be a PHP or a JavaScript expert to contribute to API Platform. A lot of junior developers are working on the project. And Justine Zahiri, on the French stage, will explain you what it is to contribute to an open source project, and especially API Platform, even when you are a JavaScript developer. So thank you for being there. Don't forget that API platform, it's a community above all. And enjoy the day. Try to meet each other, to share with other people. And I hope that after the conference, we will be able to build things, add new code to the project together. That being said, let's talk about the current architecture of the API platform project. So, API platform is an API-first framework. It's a set of tools designed to build APIs, the servers, and to consume the APIs using JavaScript. We have a lot of Git repositories containing JavaScript code to consume APIs. APIs are the way we shape the world. Most of the companies and organizations in the world now need to expose data, share data between the organization, and if you want to understand what this means to be an API-first framework, go to Mehdi's talk that will speak especially about that and how it changed the world and the legal and business implication of doing your API first. The main idea behind the project was to take care of the infrastructure part of your new APIs. And so it has been designed from the ground up to be very easy to use. That means that you just have to write a PHP class, to use the explicitity of the PHP language to describe the shape of the data that you want to expose to your API. And just with that, you get a working API. But we also have been very careful to add good defaults. And it means that these APIs that you get with these few lines of code will have the better defaults and the best defaults and will follow the best practices in the API world. The formats, the security, the default configurations, everything has been designed to be as close as possible from the current best practices of the industry. And by using API platform, just by using it, you avoid a lot of mistakes and you avoid to do poor or badly designed APIs as Phil Sturgeon will show you during his talk. Also, another core point in the design of API platform is to be able to use APIs that will be all about data interoperability, what we call open link data. So it means that by default, API platform will expose an API that can be used as a knowledge graph. And the data exposed can be shared with other operating systems. And you maybe don't know it, but you have nothing to do that. It's by default. For instance, I changed my few lines of code to add a mapping with the public RDF vocabulary called schema.org. And just because of that, other systems such as the Google search engine are able to understand the data that are exposed by our API. And so, just with this API, I generate a JSON LD document mapped with the schema.org vocabulary. The API platform client generator will reuse this data to include the JSON LD document in the generated HTML by the Progressive Web App. And when Google, the Google bot will parse our website, automatically it will be able to extract the interesting data and generate this kind of rich snippets. Who were aware of this feature built in API platform? Okay, just a few of you. Samuel Rose will give you all the details and will cover RDF and JSON LD and schema.org in depth during his talk in the afternoon. Also, supporting JSON LD and RDF out of the box gives other possibilities. As you may know, the web itself has been designed as a distributed system. But as of today, a few companies re-centralize the web, and most data and most features of the web, most data of the whole humanity actually are stored in the servers of just a few companies. There are initiatives starting to change that. And especially there is a new standard for decentralized social network called ActivityPub that is using JSON-LD and RDF. For instance, the Mastodon social network is using this web standard. API platform to the new ActivityPub component support this standard out of the box because of the foundations of the framework. So you can just install this bundle in your existing Symfony or API platform project, and then you can add your application to what we call the Fediverse, the decentralized web. And this matters because technology is not neutral. It shapes our societies. It's something very political. And if you agree with that, or if you don't agree with that, anyway, listen to Hélène Maître-Marchois on the French track, and you will have more information about that. Also, JSON-LD enables nice technical features. For instance, API platform also implements another schema, another RDF vocabulary called Hydra. And Hydra allows compatible clients to discover during the runtime all the features of any API supporting the format. And we provide another component in API platform called the API platform schema generator. The API platform, admin. And API platform admin is able to generate an administration interface for any API written in any language as long as it supports the Hydra format. And if you want to learn more about API platform admin, that is built on top of a popular library called React Admin, go to François Zaninotto's talk that will give you all the details about how to customize React Admin and API platform admin. So API platform is an API-first framework. It's even in the name. It's a full-stack framework designed to build APIs, but also to create the clients that will query this API. It has been designed from the ground up to be easy to use, to let you focus on your business logic, and provide all the needed infrastructure. And it has good defaults to be interoperable, it implements by default web standards, and it exposes truly hypermedia APIs. So it's the current state of the API platform project. What can we improve in the next version? Who is aware of this front-end architecture called Jamstack in the room? Okay. So Jamstack is a front-end development architecture. Sorry, it comes from the JavaScript world, so nobody is perfect. And as of API Platform 2.6, the JavaScript applications provided in the API Platform distributions, are following this architecture. Jam means JavaScript, APIs, and markup. The main idea behind this architecture is to pre-build as much HTML as possible. It means that basically, we will generate a static website that will be stored in a CDN, in a content delivery network. So at build time, in your continuous integration system, all the HTML pages of your website will be generated. Then they will be pushed on a content delivery network on servers all around the world. And having most of the pages already generated and stored in cache will make your website very fast. It will have a very good performance because almost no computation will be done when a user will request a page. And very easy to scale because you will just have to add more servers or replicate the content on more servers all around the world to improve the scalability of your application. So by default, in API Platform 2.6, the client-side part of the project follows the Jamstack architecture. But what is a CDN? A CDN is a way to store static files all over the world in servers. So you need a lot of servers, or you need to use a company providing a lot of servers around the world. Some of them, Vercel, the creator of Next.js, AWS CloudFront, or Fastly are common content delivery networks. The goal is to put the servers as close as possible from the end users. So basically, here we are in Lille. When you will go on a website hosted by Vercel, you will probably hit a server that will be in Roubaix or in Belgium. So doing this will allow low response times and reduced bandwidth usage. It's a good way to improve the performance of your web applications. Also, some CDN providers allow you to execute code at edge. That means that your application will become a distributed application, and you will be able to deploy your code in all the servers of the company all around the world, all over the world. And when the user will go on your web page, if it's something that cannot be stored in cache, for instance, then the code will be executed on the closest server. So this also improves the performance a lot. Usually, you can host on these infrastructures Lambdas functions or use serverless tools. It's, for instance, Cloudflare Workers, Lambda at Edge from Amazon, or Vercel. Vercel also allows to do that. And Vercel also allows you to host your PHP applications on their servers. It's something that is not very well known. And if you want to build your own infrastructure, then you can use the KD web server. That is a distributed web server, very easy to configure, that we use by default as of API Platform 2.6. And I'm very happy to say that we have Matthew Holt today with us, the creator of the KD web server, that will explain you how this works and how it can help you to improve the deployment and the run of your PHP applications. Also, there is a module for the KD server that has been created by Sylvain Cronbach that provides an HTTP cache server like Varnish, but unlike the open source version of Varnish, which is distributed. So it means that the cache can be automatically synchronized across all your servers all over the world. And if you want to try that and to try to build your own edge infrastructure instead of using something like Vercel, you can try fly.io. It's a service allowing you to deploy Docker containers, including the Docker images provided by API Platform, on a lot of servers in parallel all around the world. And it works with any Docker image. There are several strategies implemented that you can implement for your Jamstack front-end application. The first one, the most common, is the static site generation, SSG. It means that we will build all the pages ahead of time, usually in the continuous integration systems. And then the generated files will be stored in the CDN. But it means that it can take a long time to build the application, and also that it's not convenient if the data change frequently or if there is a lot of data. There is another popular strategy called incremental static regeneration, ISR, that is supported by Next.js. This time you will build the HTML right into, you will build the HTML on demand. So during the first request for a page, the page will be generated and stored in the CDN. So this allows faster builds, and this allows also to generate the page directly at edge. It's supported by Vercel. It means that the server itself will be able to generate the HTML page. And this allows to have pages with an expiration time that will be regenerated by time to time or invalidated when the data change. So it's a more advanced approach. But let's talk about APIs. I'm very proud today to introduce you a new way to design your API architecture. I called that edge-side APIs. So basically, it's applying the IDs it's applying the Jamstack IDs to the API development world. The goal will be to pre-build as much API responses, JSON documents as possible ahead of time, and to store these JSON documents in a CDN. So basically, we will try to generate all the resources that can be cached and that can be served from the API, and to deploy them in a lot of servers all around the world. If the response, if the JSON document, for instance, cannot be cached and cannot be generated, then we will try to generate the document on demand, but on the edge server. So we will use something like an edge computing infrastructure, something like Vercel or Cloudflare workers to generate the API responses. So the benefits of this approach are the same as with Jamstack. It's performance and scalability, but for your APIs. ESA APIs can be written in any language. In PHP, we will see that just after, but also in Go or in Rust if you prefer this language. ESA is built on top of the REST architecture. It means that to create an ESA API, you will have to follow all the REST constraints. And ESA will be the core architecture that will be followed in API Platform 3. So we will try to improve the framework to be able to support this way of building APIs natively. Of course, everything that is currently working and the current approach will also continue to be supported. The name is a reference to ESIs for the old with us today. And also it's a wing to the European Space Agency. So let's discover what it means to create an ESA API. The first constraint that you will have to follow is to pre-generate as much API responses as possible. So everything that can be computed ahead of time should be computed ahead of time. You following the static site generation strategy or the incremental static regeneration strategy. Both can be supported. And then the JSON documents should be put in a CDN and should be served by the CDN as close as possible to the end users. On write, when there will be a post, a put, a patch, or a delete response, the API should regenerate the document and update the CDN to serve immediately the new response. So it means that most of the time, the API response should be generated only one time when there is a change. And then the static file, the resulting static file must be served by a CDN, and no algorithm, no code should be executed for that. It means the algorithm should be executed only one time. And if you are generating responses that are not cacheable, then you must be able to execute the code of your API at edge using a supported provider. The benefits are the same as with Jamstack. It's the performance, the scalability, and the reliability, because there are a lot of servers. If a server crashes, there are a lot of other servers to serve the response. And less energy consumption, because you generate only one time when there is a change to API response. And Nicolas will explain you during his talk how you can run PHP code, and especially your API platform application at edge on providers, on the servers of Cloudflare or Lambda at edge and things like that, thanks to the new runtime component of Symfony. The second constraint that must be followed by ESA API is to create atomic resources. It means that the JSON documents that your API generates must be as small as possible. And if you want to create an ESA API, you must not use resource embedding embed the related resource anymore in your documents. So if in API platform you are using the serialization groups to create a huge documents containing all the data that is needed first and all the relations in a single API response, you don't do that anymore. Instead, you create very small documents having relations between them and using links, using URLs for these relations. So you will split the big resources into small resources. And if you have a single resource which is huge, which have a lot of properties, then you can use one-to-one relations, and what we call in API platform sub-resources, to split this big document in smaller ones. These have a lot of benefits. The first one is the developer experience. You don't have to use embedding and serialization groups anymore. You can just generate small JSON documents that will not vary. So the logic will be easier. Also, the main benefit is that the cache hit will be better. Even client side, even in the browser, you can have small parts of the data that must be displayed that are in cache, and you can fetch only what is needed when it's needed. So it's almost the same advantages as GraphQL, but with a better cache strategy. For instance, you can either cache all the things client side directly in the web browser. Also, you must, and you can with that, delay the fetching and the generation of the documents. So basically, if some data can be displayed only when the user will click on a link or something like that, then you don't have to embed that anymore in the first API response. You can split the documents and wait for this click to trigger a new request and to download only at this time the data that is needed. So this will improve the bandwidth usage and it will improve the performance. Also, doing that allows less frequent regenerations and invalidation. If you have a huge document containing half of your data in database, then you must invalidate every time there is something that changes in your database. If you have a lot of small documents, then you will keep it in cache for a long time. To do so, we need a lot of code changes in API platform. It's not the current design of API platform. Fortunately, Antoine Bluchet did a lot of work to allow us to support that in API platform. And in his talk, it will explain you how we modified the API platform to be able to implement ESA APIs. Another constraint, the API must be progressive. It means that the API must work even on low-end device. It means that even in a script, even by using just curl and jQuery, you must be able to use the API. But also, it means that if the client is something more advanced than curl, if it's the last version of Firefox or Chrome, then you must also be able to improve the user experience and the performance by using the extra capabilities of these clients. For instance, if the client supports HTTP3 or support WebSockets or supports preloading or supports cache, then you must use these features. But these features must be optional. A quick reminder, we speak a lot these days about the climate crisis. The digital has a huge impact on the environment, and most of this impact of the environmental footprint of the digital is because of the devices. Building an iPhone or building a computer is not good for the planet. And one of the solutions is to be able to use the devices more time. And it's one of the ideas behind creating progressive API. Even old devices must be able to use your API. Another constraint, preloading. Because we use atomic resources and small documents, we can have a problem. We can have the N+1 problem. We can have to do a lot of HTTP requests to retrieve all the data that we need because there are a lot of small documents with relations together. To mitigate that, we can use the preloading feature that is available in most web browsers and actually in most HTTP clients. To preload all the resources that are needed by the client, you can use what we a special HTTP header called the link header with the preload relation. You can also use the new HTTP status code, the 103 status code, entirely designed for this kind of usage, and that is being deployed in Chrome these days. Or you can use HTTP2 server push that is being deprecated and replaced by the 103 HTTP server, the 103 HTTP status in Chrome. And there are protocols to do that, and especially to let the client inform the server of what it will need. For instance, you are building a mobile application displaying all the data for this event. You say that on this page, on this screen, you will display the name of the event and some attendees and the number of attendees and the schedule. You need all of that. With Vulkan and with the preferred push protocol, you can, during the HTTP request, hint the server that you will need all this data, and the data can then use the preload links, for instance, in the browser that it will have to download initially all these URLs. So I did a lot of talk about Vulkan. You can find them on the internet and on YouTube if you want more details about that. But it's what makes ESA APIs fast, actually. And finally, you must push. At least if the client supports that, when the browser requests a data. After that, the server should push the changes made to the documents that have been retrieved by the browser in real time. So basically, if I make a GET request to fetch the list of the attendees, every time a new attendee is added or deleted, then the API must push this data to all the clients having the current version of the resource. So it means that on write, you will pre-generate the API response, store it in a CDN, but also push it to all the clients having the current version of this document. To do that, you can use the Mercure protocol that I created too, or you can use server-sent events, or you can use WebSockets, or you can use the WebSub protocol if you are doing server-to-server communications. So this has a lot of benefits too. Clients are always up to date. The UI will update in real time, so the user experience is way better. And also, it prevents of doing polling, so it will also be greener. Apple did a lot of research about that, and they said that using things like SSE or WebSockets improve the battery life of iPhones and Apple devices a lot compared to using standard polling. So this is how it works. I also presented Mercure a lot of times, so you can find the videos on YouTube too. So how to implement that now? Actually, it's a bit more complicated than that, and I'm currently writing a book about that will be published in the next few months. I don't know exactly when, but it will be soon, I hope. Also, I will be speaking entirely about ESA APIs during the Forum PHP conference that will be in October. And we are working to implement this new architecture in API platform. And especially Antoine Blucher is working on that, to be honest. So Antoine will explain you that in his talk that will begin. But if you want to see the talk of Olivier Doucet in French about how to start a new project with API platform and all the benefits of using API platform on your next PHP project, you can go to Olivier's talk too, because the talk of Antoine will be recorded, and even for people that are here in this room, you will be able to view it very soon on YouTube. We will send the links of the video in the next few weeks. Thank you very much, and if you have any question, Any questions regarding ESA or API platform or Mercure or Vulkan? Be my guest.
Thank you, Kevin. We have just a few minutes for the questions. Are there any questions in the assistants?
And you can ask your questions in French if you want, and I will translate them and reply.
You can also ask questions online on Livestorm, and the moderators can ask a question here on live.
Okay.
So there is one question there in front.
Micro, peut-être?
Grégoire, tu peux apporter un micro devant, s'il te plaît?
Oui, du coup, je suis fortement intéressé par la pré-génération des réponses. C'est un peu... je m'y attendais pas. Mais du coup, qu'est-ce qui va pool, du coup? Qu'est-ce qui va générer? Comment est-ce que c'est un cron qui tourne? Parce que ça va, du coup, consommer beaucoup de ressources, de pooler toutes ces infos. Le stockage, il va prendre énormément de place. Voilà. Est-ce qu'il n'y a pas un petit peu des drawbacks là-dessus?
The question is, if we pre-generate everything, from where come the data at first? Is there any drawback? Is it not huge to pre-compute all the resources? So the answer will be, we will apply the same techniques as in Jamstack. So basically, the first thing is that when will you do that? Actually, it's when the data will come to the API, when there will be the post or the put request, you will generate the JSON and store it. So in terms of computation, it will be quicker than generating the response for every request. But then you need indeed a lot of, it will take a lot of space on disk to store all these resources. It's true, but when you use a CDN, you can store a lot of data. Most providers allows you to store huge data, a huge amount of data at edge because storage is cheap, actually. So it's why it's used like that in things like Vercel and Cloudflare Workers. You can put a lot of things in cache. And then there are eviction strategies. So, for instance, when you are using Next.js, if for some reason the data isn't on this edge server, or it's taking too much space, there are eviction strategies to, for instance, evict from the current cache the old responses and keep only the newest, and to regenerate by time to time what needs to be regenerated. So there are a lot of research and algorithms to mitigate this issue. Basically, the idea will be to store what is the most downloaded in a warm cache, and then to have several layers of cache. And if there is a document that is not downloaded often, to regenerate it and store it in cache until we need some space and then evict it. I don't know if it's clear.
Yes, but what about the processing part? Which do you use crons or I don't know?
No, you don't have to use crons or things like that. Actually, most of if you are using a provider, so as Cloudflare or Vercel or something like that, they provide you APIs that your code must use to put the data in cache. So you don't have to use a cron or something like that. When you get the post request, then you generate your JSON, and then you use, let's say, the Cloudflare API to put this data in the CDN in real time. And then it's in the CDN, and you don't have to regenerate it. Okay? And if you are using if you want to build your own infrastructure, things like Caddy and Swan, the distributed HTTP cache server, are working exactly like that. They provide custom APIs that you have to call ahead of time when you are generating the static resource. So you never have to use a cron or something like that. You just have to put the data in the edge server ahead of time, during the generation time, and then it will be kept by the CDN. And if for some reason it is deleted, it is evicted from the cache, then it's the CDN that will be smart enough to, usually using what we call a stale while revalidate strategy, to serve the data from the cache or refetch the data in the background from the origin. So, for instance, there is a strategy in Next.js where you can say, okay, because I cannot store everything in cache, I will, no, it's not what I want to say. Let's say I want to speak a bit more about the SWR strategy. Things like Vercel and Cloudflare and things like that, and Varnish also, are able to always have some version of the resource in cache and always serve it to the user, even if it's stale. But in the background, regenerate the new document and replace the data in cache, so the next user will have something that will be fresh. So by using this strategy, then you are sure that your response times are always as short as possible, because it's almost always served from cache. But the data will be kind of fresh, because it will be regenerated by time to time in the background.
Okay, I'm sorry, we have to interrupt you. We don't have time left for questions. I invite you to ask the question directly at Kevin during the conference. We'll have a few breaks for that during this timing. Now we're gonna welcome Antoine Blucher in this place about a journey toward API Platform 3. And in the French track, we're gonna welcome Olivier Doucet about PHP and Symfony Project Reboot.
Thank you very much.